Dear students, welcome to again a movie. Today we're going to talk about supervised classification methods and more specifically we're going to talk about decision trees. So, suppose I often play sports with a friend and I keep track of when he shows up. Can I predict whether he will show up given the weather? And one way to fix this is with a decision tree. So let's say we have some features of the weather. We've got temperature, outlook, humidity and windy. This is basically our X. So this is our data. And we've got a label, plate. This is our Y. So when it was mild, sunny, humidity was 80, there was no wind, yes, we did play. And it was hot and a little bit lower humidity and it was windy, we didn't play. So can we use this data to predict the behavior of my friend? Well, one way to do this is using a decision tree. So, for instance, look at the outlook. Is it sunny? Is it overcast? Or is it rain? Yes. If it's is it overcast? Yes. Then apparently 4 times we played. If it was sunny, we looked at the humidity, and if the humidity was low, then we played, and if the humidity was high, then most of the time we didn't play. And if the outlook was rain and it was windy, then we didn't play, and if it was rain and it wasn't windy, we did play. So this is a decision tree, and again, of course, Python can make this automatically. And a decision tree has nodes, question splits, edges, path to follow, roots, and the first question, and leaves. And to show this a little bit more clearly, I'm gonna put it vice versa or top down, because basically it's the things of trees. This is a decision tree, so the root is where the tree starts. That was the first question. Then we got edges, so path to follow. We've got nodes, questions, and we've got endpoints, the leaves, which mimics quite a nice tree. Okay. So, how do we know which question to ask and which gives the most information gained? If we, for instance, have this data set, so we've got 1, 1, 1, 1, 1, 0 for x, y, z, and we've got the label, the class. Then you see already that this question, it's not really useful, right? If the z is 1 or 0, well, in both cases it can be either A or B. We see that the question x gives a little bit more information, right? Because if the x is 1, the chance that it being an A is a little bit higher than being a B. And if it's 0, then it's definitely a B. So this is a little bit more useful question. But this is the most useful question, right? What is y? Okay. It's basically about the amount of information. This is really interesting in my mind. It's about Shannon entropy. And there you see that if a thing is really predictable or really predictable this, then it doesn't have information. And if the information, it's not really, you cannot, there's a lot of variation in probabilities, then it says something about the information in that question. I'm gonna skip this because I've got a separate video on it. It's really interesting, the whole math behind this and the whole idea. And I'm gonna also skip this. So please look at the other video. But basically we wanna have something where the entropy is optimal. So if we have a question where we see really a big decrease in entropy, then we have a lot more information gained. But again, I've got a different video on that. Really nice concept, really nice. So this decision trees in Python. So what he does, he uses that entropy, that Shannon entropy, to make a smart decision tree. And again, what we know already from the last video is that it follows the same scheme. You can, that's interesting, you can also visualize decision trees. yeah, in this presentation it still said it's hard. It's doable. You can Google this, and also in my example, I visualized the decision tree. It's not always useful, the results. It's a little bit difficult to interpret the results, especially when you get large trees, because you simply cannot read the output. But it is doable. There's some problems with decision tree. If the first question of the decision tree is bad, then it could be very hard to still get good results. Sometimes an initial question that seems good turns out to be bad. And there's a way to handle this, and that's with a lot of random trees. So we're making a lot of different trees, and then we're gonna compare the results of those trees. So then we're going into random forests, and basically we make a large number of different decision trees, and let's say we've got p features in our data set, so also basically p kind of questions which we can ask. And if we want to have a new question, we randomly pick for each decision tree a question. and for those m features, we look at what is the best question that we can ask. And we repeat this algorithm each time. Sorry, my voice. Okay. With this, we can have different decision trees, and they will give, well, not per se different predictions, but sometimes different predictions. And how random forests work is that they use majority voting. So we're just gonna see which gets the most votes, and that's gonna be the label. Again, this is done very easily. Actually, here an example where you make a random forest with 200 different decision trees. Some pros and some cons. It's the pros of random forests and also decision trees. It's strong for small training set, and you don't need to do input scaling of the data. And you can use both numbers but also categorical features, which is nice. It's not so prone to overfitting. Decision trees are, because it's really very dependent on which question you ask first and which one you ask later. And the random forest is a little bit less sensible for that. And you can use it for regression too, so you could also use it to get really an output value instead of a label. And it works relatively well for problems with a large number of features. It's relatively weak with larger data sets, the performance levels off, and the training phase can take a lot of time if many trees are used, which is, well, kind of logical because you're using 200 times one tree. Especially for random forest, it's relatively hard to explain the result and the output. Of course, you can look at what each tree does, but it's not so. And then you have to see, okay, this tree does this tree does this, and then I get some kind of output. But that's a lot of work for each individual point. When you have a decision tree, it's much more clear how is the relation between input and output, and it's relatively hard to add more data later on. So a very relatively short movie about this. I made a separate movie about decision trees, and I'm gonna link to it. Good luck!